So in our class last Thursday, we spent the majority of the time going over the different sections of the IMRD report and answering the really good questions that you guys had about those different sections and kind of what the default would be like and how you might handle questions if a student had resistance or if there was variation in a particular discipline. Now, the readings that were on the agenda for Thursday, which we really didn't get to talk about much, though you brought in some of what you had learned in the reading to bear on class discussion. But the readings were really trying to get you to realize that IMRD is a general framework, but it's not a rigid formula. So it's flexible. There's variation. And this variation tends to be in response to the needs of different discourse communities, where a discourse community is a group of readers and writers that share common values and purposes for the texts that they produce and consume. So when you see variations in IMRD or variations across disciplines, and most disciplines we can consider a discourse community, and then maybe even within a discipline, subdisciplines could be their own particular, more highly specific discourse community. When you see variations, try to connect those variations to the values or needs of those discourse communities as best as you can, because if we can come up with a reason for the variation, it helps contextualize it. It helps make more sense to the student and to yourself why there are these variations. So as an example of what I mean by connecting variations to the values of discourse communities, I want you to take a look at this table here. So this table shows three different citation styles. MLA, which you're probably all familiar with, is commonly used in English, literature, languages, many humanities disciplines. APA, which is used in social sciences, in business, a lot of technical fields, and a lot of scientific fields, actually. And probably across the university, APA is more common than MLA. But everybody tends to know MLA because that's what's taught in first year writing. And then IEEE is for Institute of Electrical Engineering, something with a third E. So this is for much more technical engineering disciplines. Take a look, go ahead and pause the video and take a look at these different citations. So these two rows are for the in-text citation and these are for the works cited. Go ahead and take a look at these and see what conclusions you might draw from what kind of values, why would we have these different disciplinary styles? What does it suggest about what these disciplines value? So when I do this activity in class, usually the first thing people point out is that APA has the year in here. And that makes a lot of sense because in social sciences, APA stands for something psychological association. And in fields like psychology, really recent research matters a lot. Whereas in MLA, which is more literature, it doesn't matter as much when people say something. So for instance, if you're writing about Shakespeare, it doesn't really matter if that text, if your argument about Shakespeare was written in 1980 or 2016. Whereas if, for instance, you are doing research on gender and communication, like a lot of my research, it matters a lot whether something was written or studied in 1980 or 2016. So APA really privileges the year a lot. MLA also privileges page numbers and has much more detail about finding exactly where a quote comes from. Actually, in MLA, I have this example here with page 35, but they usually don't do that in APA, have a lot of page numbers. IEEE, there's no way to cite a page number. It's just not part of the citation practices. Now, next thing people will notice is that IEEE has uses numbers, and it orders the citations. I don't know, there should be a 1 here. There should be 1 and 2. It orders the citations in the order that they appear in the paper. And this makes it possible to do something like 6 through 9. And you can see this is so much more concise than these other ones. And concision is really valued in this technical community. Moreover, authors aren't really valued. That there's much less emphasis on who said it, who came up with it, and more emphasis just on the idea. To the extent that where these two disciplines alphabetize the works cited, in this discipline it should appear in order that they appear in the paper. So the first thing you cite is number 1, and that's number 1 in the works cited. Second thing you cite is number 2, and that's the second item in the works cited. And so this shows that authors aren't as important in these more technical disciplines. There's more based on a more sense that knowledge itself is predominant, and it shouldn't matter who says it. Whereas in MLA, of course, it's very important who says it. So when I talk about trying to link variations that you see to disciplinary values, this is a very good example of what I mean. So now let's go ahead and turn to the reading from chapter 5. And this talks about variations in IMRAD. And one of the biggest variations that you're going to see is the problem solution IMRAD. So up until this point, all of the IMRADs we were looking at were based on experimental studies. However, in applied disciplines like engineering, for instance, the research contribution is really building something new. And so this research structure reflects that. As a matter of fact, if you're getting something in a discipline like engineering, I'd say probably 2/3 to 3/4 of the time, any IMRAD in engineering is going to be a problem solution. They still definitely do experimental research, and that's much more common at the undergraduate level in labs. But when you're working with graduate students on their own research, you're probably going to be seeing a lot of problem solution. Same thing with anything in computer science. That tends to be a lot of problem solution. And so this is a little bit different structure. The introduction is very similar to the introduction of an experimental IMRAD. But we have this whole solution section that's going to have multiple subheadings that are really topic driven depending on the particular area. Then there will be some kind of evaluation, some kind of miniature methods and results, and usually a section that says conclusion. Now, what I'd like to do is let's go look at these exercises, the abstracts you looked at in exercise 5.1. So let's take a look at this first abstract here, and I'm going to go ahead and read this using the information from the next chapter on the novelty moves. So let's kind of read this sentence by sentence. Very first sentence. Physiological measures, such as pain, anxiety, effort, play a crucial role in the evaluation and development of assistive robotic devices. So this is a clear statement of significance that we want to pay attention to these issues. Then we have several statements on the status quo, that physiological data is collected and analyzed by research and clinicians Currently, these data are collected, then analyzed offline such that they are only evaluated after the experiment has ended. So at this point, once we get to the only, we're starting to signal the gap here. So, and here the status quo and the gap start to merge a little bit because the status quo solution has a problem. By the next sentence, we're clearly into the gap. This makes any iterative design process tedious and time-consuming since any tuning has to be done on a subject-by-subject basis. So this is clearly the gap. And then the next sentence begins with filling the gap. To overcome these drawbacks, we are proposing a new type of human-machine interaction. So here is how they're filling the gap, and we start moving into the solution. So close to, look, about 40% of this abstract is dedicated to the introduction, to describing the problem. And that is typical for abstracts of problem solution projects because we really need to understand the problem before we can begin to appreciate the solution. So the next sentence here, this sentence starts to go into the solution. And if you have labeled things a little bit differently than me, or you see it a little, you identify it a little bit differently, I don't want to get hung up on those small labeling differences. The purpose of these labels, the purpose of this vocabulary is to enable you to see things. And as long as we're seeing the same things, we're okay. Whether or not you say, oh, I kind of think that that's a little bit more fill the gap, and I'm saying this is more solution, they're very, very similar. And we can both see that they kind of blend in to one another at some point in this sentence. So the next several sentences here are focused on the solution, really up until we validated this concept. Now, this last sentence on validating the concept, it's a little bit unclear to me how they validated it. And when we look at the actual article itself, I think the validation section is a little bit confusing, and that's reflected here. But this is really where clearly the rhetorical goal is to provide the evaluation. So a very small amount of this abstract is focused on evaluating the technology. Now, from this master's thesis in chemical engineering, this is actually, I'm going to replace this example for the next year's cohort because I was looking at it again. It's not as clear as I remembered. What happened here is I remember what the original looked like, and this is so much clearer than the original, but I actually see a few things that could continue to be improved to make this a more clear-cut example. So I apologize that it's maybe not as clear-cut as it should be. Let me go ahead, though, and walk you through it. So first sentence, we have some language that really points out the significance here. So greenhouse gas emissions are a big concern. I think everybody kind of gets that. So carbon dioxide capture is a promising approach, and a particularly competitive technology for carbon dioxide capture is oxycombustion, and they provide a little definition of that, and that definition curves through about right here. This is all describing the status quo and what is currently a cutting-edge solution. Now, where it gets a little confusing right here, to improve the performance of these two units, most studies use SM approaches. It would be very helpful if before this, they explain a little bit what's wrong, what the problem is. As I understand it, the problem is that these two units don't quite speak to each other very well. And so And so whenever they make a change in one thing or change some part of the conditions, we have a communication problem. They haven't articulated that problem, although uh, they do articulate this status quo solution, which is SM approaches. So here we're talking about, here's kind of a status quo solution, and here's a problem within it, and here's another status quo solution to this problem. We're probably getting a little more cutting edge, and the whole progression through this abstract is kind of narrowing down to get to the specific problem that the writer is solving. So the writer's not solving greenhouse gas emissions overall. This is a smaller part of the problem of greenhouse gas emissions, and it's a smaller part of the problem of designing good systems for carbon dioxide capture and oxy-combustion systems. Now here, where they say, however, the SM method is very time-consuming and only allows a limited number of parameters. This is clearly gap language here. And the EO methods are the solution for that they are implementing, that they're bringing to the table. When I read this before, I thought maybe they were setting us up for another status quo and gap, that they were going to say EO solutions are kind of the cutting edge. This is the best of the best, but there's still this problem. To clarify that this is the solution, I would say we are using, to solve this SM problem, we are using EO methods. So there's a little bit coherence issue, though overall this first paragraph is really describing the problem and going through the 4 novelty moves and explaining how they're solving it, filling the gap with this solution with EO methods. So again, we have about, in this case, half the abstract is focused on identifying the problem. And that is pretty typical of problem solution abstracts. In the next one, I have this unfortunate page break here. All right, so then we have, they use EO methods. This is really clearly, we're describing their solution. And they describe the math that they do and some of the conditions that they test and how they do the math. We have to trust people on this, so they're giving us the highlights of the methods that they're using to solve this problem, which is really primarily a math problem to really figure out how to optimize these units and optimize the communication channel between 2 different units. Then the last sentence here explains how they assess the model. So this is the methods for evaluating it. And the very last sentence is the results of the evaluation, which demonstrates a 16% reduction. So you see, in both of these problem solution abstracts, we're ending just with a focus on the results, on the outcome of the evaluation. But a lot of time is spent in the abstract articulating the problem, introducing the scope of the research. And this is in contrast to an experimental IMRAD, such as this one from this paper in information security. In this paper, the first 2 sentences are introducing. The first sentence articulates significance of the problem and the status quo. We have either user-generated passwords, which have this problem, or system-generated passwords that have this problem. Passphrases have been proposed to be a solution for this. Now, what this abstract doesn't say that might that's missing here is that the goal of this study is to test the hypothesis that passphrases will are better than other system-assigned passwords. So here, and they left that information out for economy's sake, for the purpose of the abstract. So next we say their methods, that how many people they used, and what they end up comparing. And then the next several sections, all of this right here is articulating their results. And they have several different levels of results until we get to the last sentence here, which is focused on the discussion, the implications, that passphrases, hey, it was a good idea, it didn't work, let's not use them, is what this says. So here we have a very different focus than on the other two abstracts, where about 40% of this is dedicated to the results. Relatively little compared to the problem solution ones is dedicated to introducing the research question or problem. So this is what I wanted you to get from these, some of the variation that we might see in the abstract, which is a consequence of the type of project and the amount of space that the writer really needs to lay out what the problem is, which is very central to a problem solution type project. The last thing I wanted you to get from this chapter is that while IMRD is a general framework, that these sections can go by lots of different names. And so the next activity, looking at body in the loop, is intended to help you see the different ways that different types of headings that you might see, particularly in a problem solution paper.